Okay, hello students, I think you all are fine. In the last class, we discussed different types of integrations by integration by parts method. Today, let us continue one or two more type of this integration by parts. Let us see the question. I equal to integration of e power 3x sin 4x dx. Here the product is of exponential function and the trigonometric functions. We know the derivative as well as the integration of e power 3x. Similarly, we also know the derivative as well as the integration of sin 4x. That means we can assume as first function or second function as our choice. Here I am choosing this I e power 3x as first function and this sin 4x as second function. Now integrating by parts, integrating by parts, we have first function, that is our e power 3x, integration of second, that is sin of 4x, minus integration, that is derivative of e power 3x, and integration of sin 4x dx, and here I put dx. So I have arranged as per the rule of integration by parts. Now here, that is e power 3x sin 4x, we know that the integration of sin 4x is minus sin 4x is cos 4x and by 4. So I write 4 by 4 here, that is equals to minus integration, that is derivative of e power 3x. So e power 3x is what? E power 3x, and for this 3x we put 3 here, and again we have the integration of sin 4. So sin 4, integration of sin 4 is again minus of cos 4x by 4, and dx is here. Now this is equals to 1 by 4 e power 3x cos 4x, and I bring this minus sign out of this integration. So that is plus, and this 3 and by 4, that is 3 by 4, and e power 3x cos 4x dx we have with this now. Now dear students, you can look here very carefully that e power 3x cos 4x, that is again it is the product of exponential function and the trigonometric function. So we have to integrate it again by using integration by parts method. Now let us do once again, that is 1 by 4 e power 3x cos 4x plus 3 by 4. Here I am doing integration again by using by parts method. That means first function is e power 3x, integration of cos of 4x dx minus integration, that is derivative of e power 3x and integration of cos 4x dx. Here I close the bracket, this one. So let us continue. That means minus 1 by 4 e power 3x cos 4x plus 3 by 4. Here that is e power 3x, again it is e power 3x, integration of cos 4x. Integration of cos 4x is sin 4x by 4 minus integration, and here e power 3x, again the derivative of e power 3x is 3 e power 3x. Integration of cos 4x, that is sin 4x by 4, and I keep this dx again. So, finally that is equals to minus 1 by 4 is here, minus 1 by 4, e power 3x is here, cos 4x plus 3 by 4 times of e power 3x sin 4x by 4 minus, here again you can take this 3 by 4 out of this integration sign, that is 3 by 4 out of this integration sign, and within the integration you have e power 3x sin 4x, that is e power 3x sin 4x and dx. Here I close it. So, this means we have 1 by 4 e power 3x cos 4x plus 3 by 4, that means this is 3 by 16 plus, or you can keep minus 9 by 16, 3 by 16 e power 3x sin 4x, and this is minus of 9 by 16 integration of e power 3x sin 4x and dx. Now, dear student, look here, this is integration of e power 3x sin 4x, that is nothing, exactly this is our the question. That means we can replace this part, integration of e power 3x sin 4x dx by I. So, you have I equal to minus 1 by 4 e power 3x cos 4x plus 3 by 16 e power 3x sin 4x minus 9 by 16 I. Now, I can bring this minus 9 by 16 I to the left hand side, and that will give you I plus 9 by 16 I is equals to minus 1 by 4 e power 3x cos 4x plus 3 by 16 e power 3x sin 4x. So, this I and 9 by 16 I make 25 by 16 I is equals to, we can take this 1 by 4 minus 1 by 4 common out, that means you can take this 1 by 4 common and e power 3x also common, and this is your 3 by 4 times of sin 4x and minus of cos 4x. Now, I multiply this I get this I from here, and the final result will be something, I is equals to, that is 4 upon 25 e power 3x times of 3 by 4 times of sin 4x minus of cos 4x and plus c. So, this is the final answer. So, dear student, this way, look here what I did, I never did the integration of this part, I simply taken this part, because this part is same to our I, given I, and that is taken to the left hand side and that is added with this I, and finally we get the value of I. So, this way you can find the integration of these type of problems, especially these type of problems you can find at the product of the exponential function and the trigonometric functions. Okay. Now, let us go to some more type problem. Now, look at this problem. I equal to integration of log x plus 1 by log x the whole square dx. Here we have two terms, but I do the integration of these part only, and let us see what happen. First I make the integration sign separate to these terms. That means this is integration of log of x plus dx plus integration, that is 1 upon log of x the whole square dx. Now I can do the integration by part over this term. How? As we have done in the log case. That means log we can assume a constant 1 here, and that one will be treated as the second function. Here I assume this is log of log x as first function and this one as the second function. Then we can apply the integrating parts over these terms. That means in applying integration by part or integrating by parts, we get first function as log of log x, integration of second, that means only dx, integration of dx, minus integration, that is derivative of log x, and integration of dx, again we have dx, and plus this term plus integration of 1 upon log x the whole square. Do not forget to write this part. Now this is equal to, this integration is x, so we write x log of log x minus integration sign, this derivative is what? 1 upon log x, and for this log x we have 1 by x, I write here, and integration of this dx is x, I write here, and that will give us dx plus integration of dx upon log x the whole square. So x log of log x minus integration, see this x will cancel, you will have what? You will have 1 upon log of x dx plus 1 by dx upon the log x the whole square. Now look here, this part integration is over, we have this part and this part, okay, but still it is not same. We have 1 by log x here and we have 1 upon log x the whole square here. That means you have to do the integration over this part again, and again you can apply the integration by parts. Let us see. This term can be x log of log x minus, see, 1 by log x, and 1 by log x we also can write as, that is log x whole power minus 1 and dx, and plus this is integration of dx upon, that is log x the whole square. Now look here, we can apply the integration by parts over this term by using or by taking 1 as some constant and as the second function. So this term x of log x minus integration, this is first function, assume this as first function. So that means log of x whole power minus 1, integration of second, 1 is your second function. So 1, that means dx minus integration derivative of log x whole power minus 1, integration of dx over this has the dx. Okay, it is clear. Look here, the integration sign is here, that means I apply the integrating by parts form. Okay, this sign, I think this sign will not be there. That is first function, integration of second minus integration derivative of first, integration of second and dx, and with this we have integration of dx upon log x the whole square. Okay. So, now let us take what will come. This is equal to x log of log x minus, here I keep on bracket, that is log x power minus 1. So, that can be written as 1 by log x, and integration of dx, that will give you some x minus, and integration, that is derivative of, here is one bracket also, derivative of this one. Look here very carefully, derivative of this one, that is log x whole power minus 1, that means this will be minus 2, okay, and this for this minus 2, and you will have minus 1 here also, and that 1 by x. Dear students, look here very carefully, I am keeping this within a bracket. This is derivative of log x whole power minus 1. So, log x whole power minus 1 is log x whole power minus 2, and minus 2 is here, minus 1 is here, and for that log x we have 1 by x, okay, and integration of this dx is what, x, and keep all these things within a bracket. Here it is minus 1, and this is dx plus dx upon log x the whole square. Now, this is equals to x log of log x minus x upon log x minus this minus make it plus, that is integration, and this integration is what, this is 1 upon log x the whole square. This x will cancel, and this is our bracket is closed here I think, and this plus integration of dx upon log x the whole square. Now, the final step is what, x log of log x minus x log x by log x, and this sign is here minus integration of 1 upon log x the whole square plus integration of dx upon log x the whole square. These two terms are same now with the different sign, plus and minus. So, these two terms will cancel out, and your final result will be x log of log x minus x log x plus c. These will be the final results. So, these are other type, some other type problem. Okay. Here we did not do the integration over the second term, only I did the integration over this time, but I did it twice and get the cancellation over with the last term, and finally we got the result. So, these are other types. So, these are the types, maximum types that I have covered in this portion. Now, let us have some special form of this integration by parts. If any function is multiplied with e power x, okay, then definitely we can think over the integration by parts, but integration by parts is something lengthier. So, that time you have a general formula by using the integration by parts. So, that formula we can apply directly. Let us see one such problem. Suppose your integration is of the form I equal to integration some e power x into f of x plus f dash of x. Then if you have such type of problem, that means a function and its derivatives with sum to each other, and with the product of e power x, then what we can do? Okay, let us see what we can do. That is integration of e power x f of x dx is one term, or plus integration of e power x f dash of x and dx is the second term. Now we can apply integration by parts over these terms. The first function is fx integration of e power x dx minus integration derivative of f of x, that is f dash x, and integration of e power x dx and dx, and with this we have integration of e power x f dash of x and dx. So this is equals to f of x, integration of e power x is e power x. So this is f of x and e power of x minus integration, this is f dash of x and integration of e power x, that is e power x and dx, plus integration of e power x f dash of x and dx. Now see, this term and this term is the same quantity with two separate sign, that is plus and minus. That means these two terms can be cancelled out. So what you have? E power x f of x. So your I is equals to this one. So I equal, that means if you have fx and f dash x together with multiplied by e power x, then the result can directly be written as e power x f of x. So this one you can consider on theorem or on a special form of integration by parts. Okay, let us check some problems. See this problem, integration of e power x into 1 plus sin x by 1 plus cos x and dx. So it is multiplied with e power x. So I have to think of that special form. Now this one can be written as e power x 1 plus sin x. So 1 sin x can be written as 2 sin x by 2 cos x by 2 by, that is 1 plus cos x, that you all know, that can be written as 2 cos square x by 2 and dx. So this is equals to integration, that is e power x. I make two separate terms over here. This is 1 upon 2 cos square x by 2 plus 2 times of sin x by 2 cos x by 2 by, that is 2 cos square x by 2 dx. Now this is equal to integration e power x. See, this is what? 1 by 2, this is 1 by 2 and sec square x by 2. These two can be cancelled out. Cos, 1 cos from the numerator and 1 cos from denominator can be cancelled out. So you will have sin x by 2 by cos x by 2, that means tan x by 2. So that is plus tan x by 2 and dx. Now dear students, see, this term is tan x by 2. So if I consider this is as fx, then its derivative, if you consider fx as tan x by 2, then f dash x, your f dash x will be what? That will be tan x, derivative of tan x is sec square x by 2, and for that x by 2 you have 1 by 2 here. So that means you see, this is fx, so this one is f dash x and it is multiplied with e power x. That is something looking like our special form, f of integration of e power x into f of x plus of f dash of x. So you no need to perform integration over this, you can write direct answer, and that answer will be what? Your answer will be e power x tan x by 2 plus c over. This way you can perform the integration of this special forms. Now I will tell you some 3 important formula or 3 special formula of this integration. Now look at this formula. These are the three special formula of this integration. That means integration under root of x square minus a square, integration under root of x square plus a square, integration under root of a square minus x square. See, remember that 6 special integrations. 6 special integrations was, that is 1 upon x square plus a square, 1 upon a square minus x square, 1 upon x square minus a square, and in the next 3 the roots involved in them. The same thing here, the root under these terms or root under these things are in the numerator. Okay. There it was in denominator, and that special forms what we are getting, see, x by 2 under root of x square minus a square, the same thing repeating only with x by 2, and minus a square by 2 log of this one. Similarly, integration of x square plus a square dx is equals to x by 2 under root of x square plus a square by 2 log of x plus under root of x square plus a square plus c. And third one is what? Under root of a square minus x square dx is equals to x by 2 under root of a square minus x square plus a square by 2 sin inverse x by a plus c. So, these are the 3 special forms, and I think these are the last 3 formulas of this indefinite integration. These theorems or this formula we can find by using integration by parts. Here we can consider this is as the first function and your 1 as the second function in all these cases, and we can derive. In the next class I show you how to derive these forms and how to apply this one in our questions. So, dear students, I think you have enjoyed today's lesson. We are just about to ending of the indefinite integration. After that we can start the definite integration. So, you practice well. Integration is all about your practice. As much as you can practice, your score or you are the master of the lesson. Thank you.